Magician's direction.
I know. So Alfonso, I put together essentially the whole pipeline that I have for ACE so that we could look at it and make sure that the config files are doing what we think they're doing and sort of some of the stuff you were talking about by email. So if those
Sounds great.
it would be really great to go through that.
Perfect.
Awesome. And I put all my config files in this presentation so we can also look at those as well. So just to sort of orient you both to the groups that I have and how my participant file is set up. 12 like adolescents in the control group, 16 in the ASD group. And the way my participant file is set up is I have, the main things I'm going to be talking about is control and ASD I have set like this. Motion is centered across all subjects. And the other thing that I'm going to talk about is novel words per minute, which I only have a value for the ASD group. Okay. So I have two pre-processing pipelines. One is our standard one for M&I space in the volume. I haven't changed any of the steps. The only thing that's different for ACE is the very liberal art threshold, but everything else is the same. And then the other one is used for the single subject, which is like the free surfer pipeline. Again, this is the default steps. This was the default smoothing, so I kept that, but I did include my more liberal art threshold. So those are the two potential pre-processing pipelines. First level is pretty straightforward for both of what I'm doing. Speech minus baseline, for what I'm talking about right now, I don't actually change the smoothing level that much. I know we've gone back and forth with that. I sort of just keep it on the maximum smoothing, which for the free surfer pipeline is only one level of smoothing anyway. So I've just sort of kept it on the max for both.
Yeah, that's perfect.
Yeah, and then the covariates here, I'm doing motion, linear, and art. And this is a sparse design. So I'm not having any high-pass filtering, not worrying about the model basis or model serial. So this is my first level for both pipelines. Good?
Looks perfect. No,
Great. And then second level. So I have two here. This one is what I'm assuming, this is what I believe is happening. So this is where I really want to make sure. So this is my, within the control group, I'm looking at speech minus baseline for all of my subjects that have the control, so all my control subjects. And then these I just left as one. So based on how I set up my participant file, is this okay?
Is the control variable in the participants TSV file something that has ones for the control subjects and zeros for the other guys, or how is it defined?
So this is taken from the first two lines of my TSV file.
Yeah. Okay,
so
that sounds perfect.
Okay, great.
So yeah, that looks perfect. And just to double check, when you run the analysis, you should see the number of subjects being equal to the number of subjects in the control subset only, basically, for this analysis.
Yes, I do. And the other thing that I will send around an email, because I meant to do it, I was telling Saul about this yesterday. I had emailed Alfonso about controlling for motion and when to control for motion and that sort of thing. So I'm controlling for motion on the first level because that's within a subject. So like scan to scan motion, and that's something that's important to take out. But within a group, I don't need to control for motion because it's sort of controlling this like to an arbitrary zero. But when I look between groups, I am controlling for motion because I have group differences in motion.
Exactly, yes.
Get a really clear explanation.
Right, and the motion covariate exists for every subject, right? It's not, it doesn't have any missing values or anything like that.
No, so for every subject there's a motion covariate. I also have, which I'm not using right now because I'm not splitting up the groups, but I do also have a motion control, motion ASD, which is, this was updated. It's essentially value, this is the same, but it's essentially just this value. I just reset it by motion.
Excellent. And which variable, which motion measure you use for motion, basically? It's like the average scan-to-scan motion, or what is it?
So I'm using mean motion.
Okay, cool.
And then I've centered it. But I'm not, these I'm not really using right now because I'm not looking at anything within a group. But yes, every single one of the subjects has one of these values.
Right. And how big is the difference in motion between the two groups, out of curiosity?
It's significant. I have to look at what the actual value is, but it's highly significant.
Okay. So it might be worth looking at the distribution of motion covariates. Is it because you have a few subjects that seem to move a lot, or is it because consistently the entire group moves? Or the distribution of motion covariates relatively like normal? Things like that might have an effect. So just to double check, it might be interesting to look at the motion covariate basically in a little bit more detail to get a sense of what is.
It's actually pretty, I'll look at it again. It's a really good point. It's consistently within the entire group. This is excluding 5 subjects who had extreme motion. So I sort of plotted every single subject by their motion, and I have this nice curve up to the last 5 when it sort of exponentially jumps up. So
Excellent.
we move those last 5, and so that all the subjects do have a nice sort of linear, sort of exponential increase, but it's not, there's no more sort of outliers.
Right, and those subjects that you are removing them directly by entering missing values in the control and patient covariates, or how are you removing them?
So they're in my TSV file from just having all of them in there, but they have NAs for all of their values.
Okay, fantastic.
So I don't want them pulled in for anything. I just want to document this in there.
Okay, everything looks perfect then.
So then these are my within group. And then just to clarify, because I think I got confused about the contrast within variable. Am I supposed to be changing that at all?
Well, that only matters when you have multiple contrast names. If you enter multiple things in the contrast name because you are entering multiple conditions into your analysis, then you might want to specify which particular contrast across those multiple conditions or things that are happening in the scanner that you want to evaluate. But in the case that you are just entering a single first level contrast basically here, then your contrast within is always going to be 1, so you don't actually need to include that line. You can just remove it entirely. By default, it's going to be 1.
Okay, great. Just want to make sure that makes sense. I'm laying one contrast. Okay, so these are my just within group analysis, and then my between group, I include control, ASD, and motion, which is centered across both of those groups. And so it's control, ASD, and controlling for motion. This one, what I was intending to do was looking at, so within every member of the ASD group has this novel words per minute number, and no members of the control group have it. So my question was, within the ASD group, how is novel words per minute, is it correlated with fold activation? So that's what I was trying to get at here.
That looks perfect. It depends. Well, it's going to work either way, I guess. But the NVM variable, does it have zeros or does it have missing values for the control subjects?
It has NA.
Okay. In either way, it would work because ASD has zeros for the control subjects. So either one has a missing value basically, or both of them are zeros. So those subjects are always removed. So yeah, that looks perfectly fine. That is looking at the correlation between activation, the speech minus baseline contrast, and the NVM covariate within that group only.
And I'm not sure if I want to, but if I wanted to add age as sort of a covariate of non-interest here, I would make in a specific ASD age category where I only had values, just to be safe, I'd only have those age values for the ASD group, NA for the control groups, and then my contrast would be 0, 1, 0.
Right, exactly. I mean, that depends whether in this case, it would depend whether you have entered a number or zeros, whether it would matter. So if you have just a age covariate across all subjects, and the NVM covariate has missing values for the control groups, it would still work even if you have a single age covariate. But in any way, it's safer to do it as you were saying, basically to have an age covariate only within ASD, and age covariate only within controls, and enter that additional age ASD covariate here as a third covariate, and 0, 1, 0 for the contrast.
I'm not sure if I want to do that, but if I did, that would be there. Yeah.
Right. And then it matters in this case, what was NVM again? Could you repeat what it means basically?
Yeah, it's novel words per minute.
Novel words per minute. And how do you expect that, if at all, to correlate with age?
So I think it positively correlates with age, because there are more novel words per minute in the older children.
Right, and when you want to look at the correlation between activation and novel words per minute, you want to correct for the potential influence of age in that correlation, right? Is that conceptually what you want to do?
Yeah.
Okay, so then you are perfectly fine. The way you are doing it is perfectly fine, because the control covariate that you are entering, because you are not orthogonalizing or doing anything more fancy, you are effectively removing anything that correlates with age when you are computing what is it that uniquely correlates with the novel words per minute. So that would work as you want. So that's perfectly fine.
Is there a better way to do that, do you think? Or
No, I mean, that's why I was asking if the idea of introducing age is as a control covariate. You want to correct any potential associations between speech minus baseline activation and number of words per minute that may be actually mediated by just age difference between those subjects that, I don't know, older subjects have higher activation and older subjects also have more words per minute. And that also creates an artifactual association between activation and your NPM covariate that is mediated by age, and you want to correct for that. For that scenario, what you're doing is precisely what the best way to do it.
Okay, and then for this variable, this behavioral variable of nominal words per age, I have a wide variety of values, but they're not normally distributed. Even when I center them, it's a bit. There's one that's like 400, and then most of them are about 20. So I was actually thinking of just doing rank ordering them and doing, so if I just ranked them, this would give me a Spearman's correlation. In my TSC,
well, it's not exactly the same, but yeah, that would be the idea. I mean, the question is very good and it's very general, so it applies in general. When you're doing a correlation between some covariate of interest, that might be a behavioral covariate or something like age or like demographics or I don't know, and activation, you have to somehow think about what is the nonlinear transformation of that covariate or the representation of that variable that you expect best to correlate with activation. Do you expect to, and the question is mostly looking first at the histogram of those covariates and seeing whether there are outliers, whether it's a distribution that is relatively normal and not. But then the question, the important question at the end is not actually the shape of the distribution. It doesn't, the general linear model doesn't expect you or force you to have for covariates to be normally distributed or to have any particular distribution. They could actually be binary variables and it would be perfectly fine. So the question is not about the validity of the GLM, and the question is about the sensitivity of your analysis, and the sensitivity are going to be optimal when the actual shape of the association between your covariate and the activation effects is best characterized by that particular variable. So if you expect, for example, to be some kind of like leveling off effects that, I don't know, subjects, let's say age, for example, subjects with how activation changes with age. Do you expect it to be somehow linear, or do you expect it to basically at some point level off and just for subjects older than some value, the activation kind of levels off to some higher value than to subjects that are younger than some particular value? So if you conceptually try to plot what you would expect that association to be, that is that tells you what is the best way to characterize that particular variable in whichever way you expect it to be best associated with activation. So in this case, it's kind of like the same. If you have some subjects that if this covariate has like a very extreme outlier subject that has like 400 and the other guys are around 20, if you expect the activation to actually be mediated by the raw values of that variable and the subject that has 400 to be that much higher activation than the subjects that have words of 20, then that will be the optimal representation. But if that is not a reasonable assumption to make and you want to make a little bit of a less stringent assumption between the shape of the association between those covariates, then something like rank sorting or just like manually normalizing your covariates, so that also is a reasonable approach. You rank sort them and then you convert those rank orders into C values to get a normally distributed covariate that shows a little bit of leveling off instead of a linear association if you just sort the subjects by that. But there is no optimal, the moral of this is that there is no optimal way of doing, at least not theoretically. You have to basically ask the question of how do you expect the association, the activation to correlate with this covariate, and depending on the answer to that question, that is basically how you should model that particular covariate, and that is the linear transformation that you should seek.
That makes a lot of sense. So I think in my case, I'm using novel words per minute as sort of a imperfect stand-in for just how verbal they are. So I don't actually expect those numbers themselves to be that important. We're trying to capture some idea about how verbal they are. So I actually think I'm going to rank them because I don't think that.
Right. But is there like a categorical construct? I mean, do you expect them to fall into nice categories that the people that have like more words per minute, for example, have different processes and they might be grouped together compared to the people that have fewer? Or do you expect that to be like a continuous effect, that the more words per minute you produce, the more of an effect you find?
Yeah. because the other thing that I'm not considering here is they do have sort of, this is just overall the ASD group, but based on a whole host of behavioral measures that our collaborators did, they do actually have designations as language impaired, verbal, or minimally verbal, which pretty closely compares to the novel words per minute. So maybe now that I'm saying it out loud, maybe this isn't the right way to do it. Maybe I go by their categories and do, you know, in an overview, looking at the different categories. I'll have to think about that more, but that's a good point to just think about what I'm trying to model.
Right, and think about also the implications of the if you find a significant effect, how are you going to be interpreting that? Are you going to be interpreting as there is some particular subset of subjects that have this like different behavior than the rest, or are you going to try to interpret it in terms of like the I don't know, like the more involved or the more attention the subjects need to pay to the task, then the more activation you're going to find, or it depends a little bit on what is it, the interpretation that you are kind of like seeking the best model that might capture that.
Right. Thank you.
Yeah, no problem.
Yeah.
So in variable, yeah, we will not use one. What variable has on the moment?
It is not really words per minute. It's an approximation of an approximation. It's not, they took the total amount of words they did over the total time, and it just some of them come out like really, really high. I have to look at it again. It's from an overall transcription. That's the thing. It's like an imperfect stand-in, so it's not really novel words per minute.
Right.
But it
Just with the value like that, I would be like, it would seem more likely that it would be 40 than 400. You know, I'm
Yeah,
just wondering
yeah.
if there's like
It could be. I can check their SALT transcript again. The other thing is it doesn't mean they're intelligible words. I mean, it doesn't mean that it doesn't mean it's not echolalia and string of consciousness, right? Like we're talking like
I know, but even like as in
like the
a
amount of
speaker,
time. Yeah.
like even like a healthy normal,
Yeah.
you know, us
Yeah.
speakers, like we speak at what 160 words
Yeah.
per minute, you know. So then that's the only thing that it's like it's not even within the realm of possibility.
Yeah. I'll check the SALT transcript.
Yeah,
Let's
just in case. That
Yeah,
would-
no, it's a good point. Those are values that were given to me from someone else.
Yeah.
So I'll just check the stuff. But even so, even if it's 40, it's still a lot more. That's a great
Right.
point. No, it's a great point. Yeah, I'll see if we get that. And it could be that one's not. That one was a carryover that's not normalized by the total time. Because that could have been the total number of words that they said.
Right.
Yeah. That makes a lot of sense, actually. I'll check that. Because that's what they should have all been carried over. But I'll see what. Yeah, I don't know. I'll check the right tab. That's a really good.
I just found it like so.
Yeah, I think yeah, I think that that's now that you're saying that, I think it's probably not normalized. Good point. I will check that. And then yeah.
Oh, I was just gonna say, so you mentioned adding an age covariate.
Yeah.
And I think in doing that, and correct me if I'm wrong, Alfonso, but it would be best to center the age variable if you were not trying to, because if you didn't center it, then it would evaluate the activation at age equals 0. And you don't, that doesn't really mean anything.
Right. If you wanted to look at the contrast, like a 1-0 contrast here, for example, in the one in the right here, the ASD group and novel words per minute contrast. If you, for looking at the 0-1 contrast, it doesn't matter whether you center the NVM covariate or not. But if you want to look at the opposite contrast, like 1-0 contrast instead of a 0-1, and you want to look at the average activation of ASD, then that will be at the 0 level of the NVM covariate or age covariate if you use that. So in that case, it's important to center them at the level that you want to explore. But when you're looking at just the correlation values and you don't care about the baseline, they kind of like intercept value of the regression line, then it doesn't matter whether you center or at which level you center the covariates, because you're never asked about the y-intercept. So.
Right. So if age was added in as another covariate of non-interest, that you'd want to center in order, if you were trying to get the correlation of the novel words per minute.
It wouldn't matter if you. It would. I'm not sure if I understood correctly, but if you add age to this contrast, it doesn't matter, and you still look at the 0-1-0 contrast in this case, which would be like looking at the novel words per minute after correcting for the correlation with age. It doesn't still matter whether you center neither the NVM or the age covariates. The values that you get for that contrast are precisely the same, because that contrast is actually looking at the difference in the not exactly. It's looking at the slope of the regression line. It doesn't care about the where does it have a y-intercept. So it doesn't care about the actual zero values of that particular any of those covariates. It cares about how strongly in the ball activation increase per unit of NVM variable or H variable if you look at the 001 contrast. So it doesn't care about the absolute zero level. Is that the question or?
Yeah, that makes sense. Great.
But in either case, if you wanted to look at the 1-0 contrast in this case, or a 1-0-0 contrast in the case where you add H as a third covariate here, in those cases, then yes, you need to worry about how you center both the words per minute and the H covariate, because that zero level of both of those covariates will be at the level at which you are evaluating the average activation for the ASD subgroup. So that is where zero levels become important.
Alfonso, you know how we were talking in the last week about organization?
Sorry, I'm hearing it very. Could you get a little bit closer to the mic or
Is this better?
only slightly? Perhaps is it that I'm hearing better this side of the room? Perhaps is it that I'm looking at the mic from the computer as opposed to the mic on the table?
Yeah, that's the problem. Yeah, we are having some mic connection issues, but
Okay, just speaking louder, it will fix it. Don't worry.
all right, I can just move down. So I can at least try switching the mic to see if that one works better.
Switch. How's that? Is that any better?
I hear perfectly fine now. I don't know if it's better, but it might be because you moved.
I have moved off. Yeah.
I just wanted to bring up here about the orthogonalization that we talked about in the last week for the first level of analysis. And I know we had touched on this before, but I had kind of forgotten that it was a thing. So just it might be relevant. So on the right hand side where, let's say you did have the NVM covariate as well as age, then the default SVM behavior is to orthogonalize those variables. So then for age, you would just be getting like basically the residual of age, right?
Sorry, it's kind of breaking up and I'm having a hard time hearing. Could you just move a little bit closer?
Let me try. How's that? Can you hear me?
Yes, I can hear you perfectly fine.
Yeah. Exactly. Oh, everybody listen.
It might be the frequency content of the voice.
The question was, if you should ask about orthogonalization. So
Right.
it being, if we looked at something like this contrast that I just put back up again, the ASD, NVM, and age, is there something that's looking at just the residuals of age? That wasn't the question.
Yeah. As in, are these being orthogonalized? Is that the default?
Yeah. Are they being orthogonalized?
Right. So when you're looking at a contrast, so the question is how orthogonalization work in this context when you're looking at multiple covariates like words per minute and age. When you're looking at the 0-1-0 contrast, when you're looking at the statistics of an effect like this, you're always looking at the unique effect. So you are always, because this kind of like comes down to the way that the statistics work, that they have like a null hypothesis. There is a model that is precisely the same, only that the contrast that you're specifying is just zero. Then basically it's comparing two models, and it's comparing one model that actually has NVM and one that doesn't have NVM, but it still has age. And it's just how much better the model gets when you add NVM to the model, how much better the predictions get, is what the statistics are going to tell you. So because of that, mathematically or numerically, what you always are testing is the unique effect of NVM or of your covariate. In this case, is how much the NVM adds to a model that doesn't know about NVM, but it already knows about age. So anything that can be explained about the activation by the age of the subject is already included in this null hypothesis model. So the effect that you are evaluating when you're looking at the 0-1-0 contrast is the effect that NVM adds on top of age. So basically correcting for the effect for what you already knew by knowing the age of the subjects. So that's what happened with the statistics. So in like numerically, again, it's exactly the same when you're looking at a contrast like this. Whether you orthogonalize age with respect of NVM, you will get exactly the same thing. So you, instead of adding, whether you orthogonalize NVM with respect of age, you will still get exactly the same statistics for this analysis. So if you look at the unique effect of NVM and you have orthogonalized NVM with respect of H, that you get exactly the same as what you would get if you haven't orthogonalized NVM with respect of H, because of the nature of the statistical test, that it always looks at the unique effect. But there is an orthogonalization in this case that works kind of like in the opposite direction. If you orthogonalize H with respect of NVM instead of NVM with respect of H, then what you are saying is, well, the H covariate doesn't know anything that can be explained by the NVM. That's what happens when you orthogonalize H with respect of NVM. So you are knowing what is that I know about a subject's H if I know his level of words per minute. That is like a predicted level of H by given the words per minute. And there is going to be some residual, which is the difference between the actual age of the subject and what you thought you knew, how well you could predict his or her age based on the novel words per minute. So that residual is the orthogonalization result of orthogonalizing H with respect of NVM. So if you do that and you orthogonalize it with respect of NVM and add that as a covariate, then when you are looking at the null hypothesis model, one that doesn't know about NVM, that only knows about this H orthogonalized H covariate, that is a different model. That is a model that doesn't know all that is to be known about the age of a subject. It only knows about all that is known about the age of a subject that is not already explained by his or her NVM covariates. So in that case, when what you are evaluating a 0-1-0 contrast, like in this case, and asking what is the effect of NVM, now you are evaluating what is the entire effect of NVM, whether it's actually explained by age or not. So you are not evaluating, so this doesn't work as a correction because you are not trying to correct anything that already, that you could explain about the activation, that you could already know about the activation given a subject age. You kind of like disregard that, and you are only trying to estimate what you know about the activation given the additional information that NVM brings to the table. In this case, when you do that opposite kind of like normal orthogonalization, you're asking the question of what do I know about the activation if I know NVM entirely. It doesn't matter whether it actually correlates with age or not. So basically, it's the total effect. This is kind of like in the regression nomenclature. Instead of looking at the unique variance, you're looking at the total variance explained by NVM and total variance in speech minus baseline. So that's kind of like how the orthogonalization works in this particular case, or in general. It depends in the direction in which you orthogonalize. Typically, if you are looking at an effect, a contrast like this, that is, you care about NVM, then it doesn't matter whether you orthogonalize that covariate versus the other covariates. The results are going to be precisely the same as if you don't orthogonalize it. But it does matter if you orthogonalize the other covariates with respect of the one that you are going to be evaluating, because that is basically adding to the effect of the covariate that you are evaluating all of the effects that may be actually correlated with these other covariates. Does that make any sense at all?
Yeah.
Alfonso, if you, what would be the difference? Oh, so you said there would be no difference if you were to orthogonalize the one of interest on the other one?
Right.
And okay, would you still include the second, like, let's say you were orthogonalizing novel words per minute with age, would you still, and then you have that residual that you want to include in the model, would you still include age, or would that not make any sense, or would it not matter?
It would matter. It wouldn't matter to the like effect size, but it would matter to the statistics. Typically, you would affect also enter age. The orthogonalization acts a little bit like an ordering of your covariates, so to tell the system that you care about one more up than another one, so to speak. So it's kind of like when you do like a stepwise regression and the order matters. Orthogonalization works a little bit like that. It allows the GLM model to impose a particular order of the covariates, so that all of the things that might be jointly explained by multiple covariates gets associated with, gets kind of like aggregated into the effect, accumulated into the effect of one particular covariate of interest. That is the one that you are like not orthogonalize it against, basically.
Okay.
Okay, so I have just a couple result slides just to make sure I am interpreting them correctly. So this is the volume. So
before we get to the results, do you mind if I, since this is a little bit of a summary of the like configuration files as well? I mean, this is very nice because it's kind of like an overview of all of the configuration files. Do you mind if I go and add a couple of comments about the configuration files in the different steps, just for clarity purposes?
I also have ROI files files later if you want me to do that, and then we can.
Oh, that's fine. Okay, then finish, and then we'll come back to the. Yeah, that's perfectly fine.
So for ROI for single subjects, for single subject ROIs, I pull in each individual SL Park PG ASED file from each subject. I flag single subject as one, and then I list all the ROI labels that I want to do there. If I wanted to instead look at all of those as a group, I would do the ROI group flag, put a name that's not a label at the top, and then list all those labels underneath.
Exactly.
The thing that we did find, I don't have it here, but you see how it comes out with on the bottom here. Or you can see that one. There it is. How it comes out on the bottom here with my ROI name. So I call this FSS
Right.
both Hemi. So when you do if you want to do group, you have to put this.
Right. That is well, it's not a bug. I mean, it's part of a feature, but I can fix it. Yeah, the thing is, because sometimes you define when you define the ROIs for a particular analysis, you might specify multiple sources or multiple Atlas files, for example, and you want to do the analysis across multiple of those ROIs that are defined through different files. So when the toolbox is kind of like extracting the information for every ROI, it's kind of like prepending the ROI, the file name, so that when you have the same label through two different files, you don't have any collision of potential, like having the two names twice. But in the case of just having a single ROI file, it doesn't make sense to add that. So I can just add a little thing to the code, so that when you have a single ROI file, it doesn't necessarily add the portion of the file name or the ROI name to the labels, so that you don't have to add that manually also when you enter the groups or anything like that.
So that's the name of my ROI file.
Yeah.
Oh. Yeah. So I'm called ROI, and then it's free first subject underscore Hemi. Yes. And so when I do a group, I didn't have one here, but when I do a group, you essentially put that whole thing in there. And that's so that you can do multiple ROI. Separate ROI analysis, and then one layer. Yeah,
But it doesn't say any script here.
Yeah. And then I didn't pull in an ROI file for if I was just doing the volume analysis, but when I'm doing the subcortical ROIs, I have that whole big list of spherical ROIs that Elaine has put together. So my ROI file has all of those things in it. And if I was doing I don't think I'm actually doing anything else. But if I was doing just like a template or something like that, I would put that ROI file in there. So for the volume, it's the same thing, and I don't need the single subject flag. And then for the single subjects, that's where it has to just point to the individual folder, and then the labels have to match up with the labels that you have here.
Right. I'm thinking perhaps it might be a good idea to add some additional quality assurance plots in here, because we don't have an easy way to kind of like check the correlation between the ROIs that you are specifying and the actual functional data. So it might be a good idea to create some display that shows you just the functional data. It doesn't need to be anything fancy, just so that you see where the brain actually is, and then the location of your ROIs in that plot, to make sure that everything is in space. So that, for example, if you are using the subcortical ROIs that are defined in M&I space, and you are using something that is not, the functional data is not actually in M&I space, you get some visual aid that tells you that something went wrong in there, as opposed to having to figure that out. Like, those are kind of like difficult things to figure that out otherwise. So, okay.
And I've been using a lot the sort of the plotting that you showed us, just to look at each subject's
right, exactly.
across the ROIs, because that helped me find one subject that I went and looked, and I realized they only have 15 ballot files, and there's a reason that they look different, so then I had a concrete reason to remove them, and now it's, took a lot of the variability out just based on the fact that I was able to look at it through the ROI. So that was really helpful to see that.
Okay, fantastic.
Yeah. Okay. All right. So that is all of those things I have. So those are the config.
Okay, it was just a couple of minor comments, just because we have been kind of like developing this whole FL pipeline. In the process, there have been some kind of like leftovers that perhaps I didn't clarify much. For example, the subjects field is pretty much unnecessary in most analysis now, because it's going to be strange the case where you want to manually specify a different subset of subjects than all in the experiment. Typically, when you want to select a subset, you do it using the particular control covariate in the participant's TSV file. So you don't no longer typically use the subjects field when creating a second level covariate. Sorry, when creating a second level configuration file, you don't need to add the subjects subfield. And then in the previous, if you can you show the preprocessing configuration files that you show at the beginning, that one. Yes, I think this one is a little bit old just because I'm not seeing there I think the only difference between that and the one that currently we have as default in the like example in the FL folders is that it adds labels. But other than that, it should be exactly the same. If you look at the second one at the next preprocessing configuration file, you see that it has some lines that say functional label as original and functional label as something. And this labeling of the data at different steps of the preprocessing pipeline allows you to then, if you want, basically when you specify first level analysis, to say, well, I want to look at the original data, or I want to look at the whatever data, and the whatever name is basically one of those labels that you have assigned at the different steps of the preprocessing. So now our preprocessing pipelines, the more modern ones, they have all of these functional label as something in sparse, like in between, just to give you an easier way to access different steps of the preprocessing pipeline in case you need to do that at the first level analysis later on. Let me see, was there anything else that I wanted to comment on this? No, this is just fine. Oh, and first level. Oh, yeah, and the model session thing, I think we are leaving it by default to be 0 now. This was one thing that at the very beginning when we were kind of like creating the FL pipeline, it wasn't entirely clear what we wanted to do or not. I think by default, it's a good idea to leave it at 0 because we have all of these cases where the number of outliers in one particular run might be excessive and the number of like valid scans that you end up in one particular session compared to another one are very different. And because of that, trying to evaluate session-specific effects might be too problematic and too noisy and give us all of these like biases because some particular runs will be much noisier than some others. So I think that is also have become the default now, the model session 0. So you typically also don't need to specify, but just to keep in mind that is also happening because I imagine that in some other cases you might not want to do that and you might want to actually try to estimate session-specific effects for, I don't know, whatever reason. Sometimes you want to do like cross-validation across sessions or something like that. And for that, you need session-specific effects, for example. And I think that's it. I don't think... I don't recall any other comments that I thought about when going on. Do you have any particular questions, any of you, about all of these configuration files or something that wasn't very clear at the time when we went over this?
Since I'm using the older pre-processing one, do I need to rerun it, or is that more just a labeling thing?
No, it's just the labeling. I don't think anything else has added. Just in the config file that I uploaded as in the FL folders, I just added the labels as part of it, just so that we would have that. Since you are not using those labels anyway, you don't need to run it, you don't even need them. I just wanted to comment just in case you see the actual preprocessing pipeline there and you see that it's a little bit different than the one that you use and you worry about why are those differences there.
Okay, great. Questions? Mind if I just look through my notes quickly? Yeah. So this was the volume, the whole brain volume analysis. For everything that I'm showing, I don't have any between group differences, so I'm just looking within group. So within the control group, this is P less than 0.001, and then within the ASD group, it's P less than 0.01, but that's not parametric.
That's speech minus baseline.
This is speech minus baseline. There's so much variability in the ASD group. It's just.
Is there a massive difference in the number of trials that are valid?
I haven't looked at that in this new group, but there's difference in motion. This is correcting for motion, but that's one thing that I can't get a handle on, right? Like, I know that I'm putting motion into my model. So in my between group differences, that's being taken care of. But I think the reality is, if I'm understanding it correctly, the amount of motion is going to affect whether we can see, if there's a lot of motion, then it's not gonna, the contrasts are gonna come off in slightly different areas.
Right. If you want to correct for that, basically try to, you can still add motion covariate to this within single groups, only that enter the motion covariate that is centered at the group specific average. So if you enter the motion variables in the ASD group as the motion ASD covariate, and you center those variables so that the average within the ASD group of the motion is 0, then it's going to tell you basically when you look at the 1-0 contrast that is looking at the ASD effect. So you have ASD and motion ASD and enter a 1-0 contrast. It's going to tell you still the same thing that you're looking at, the average activation within the ASD groups. It's only going to be, well, correcting. It's not going to be correcting for the, well, the 0 level of motion is basically the average level of motion for this particular group. So that is fine. It's still going to be showing you the same speech minus baseline activation. But what it's actually doing is discounting from the residual variability in the unexplained activation anything that correlates with age. So it's going to increase the sensitivity of this analysis without actually showing you, well, without actually changing bias in the results. It's still going to show you the same effect sizes, but with less variability, less residual variability.
That makes sense. We're going back and forth on that. I think that makes sense. So I'll have to rerun it again. One thing, and this may be totally different because I was looking at motion centered across both groups. But now that I've run it again, in this particular case, within group motion within a group. But when I was looking at it before, the control group, and I included motion, again, not corrected the right way, but when I included motion as a covariate of interest, I lost a ton of power is in a speech minus baseline contrast.
But how was it centered, the motion covariate?
That's the thing, is I'm wondering if that was all because it was centered across both groups. So yeah, I'll run it again and see what it looks like. I was just really
right. Centered, yeah, if the two groups have very different motion variables, then when you're looking within a group and trying to extend like to predict what will be the activation level at this other totally unseen kind of like motion level, it's going to do like an extrapolation of your data into that range of motion. So it's always a little bit of a guess of what is happening there, and that introduces a lot of noise. The main thing is that guess is what you actually need to be able to actually correct when you do the group comparison, and that's probably why when you're looking at the group comparison, you are not seeing much, because in order to do a group comparison correcting for the difference between the amount of motion in the two groups, you need to do that extrapolation. You need to look at the activation levels in this group and kind of like extrapolate what will happen if these subjects were moving much more kind of like in the center of the two groups, and the other group you will do kind of like the opposite and say, I have these groups, this activation level, what will happen if these subjects didn't move that much, and bring them a little bit to the center of the two groups. And that extrapolation of the data, if the data is really that different between the two groups, is what is creating this additional, well, unexplained variance and noise in the data, and that's why you lose power. But that is at the very, if you do the centering within each single group, when you're looking at the speech minus baseline activation, correcting for motion, but motion being centered separately within at the average level of the motion within this group, then the effects are not being extrapolated, because you are looking at the 0 level of motion, which is right at the center of that particular group that you are evaluating. So there is no extrapolation, and that's why that should, at least those results should look perfectly, well, much more reasonable. Only that doesn't help in the comparison between the two groups, because for the two groups you do need or do want to actually try to extrapolate the data beyond the normal range of motion for that group. Make sense?
Yes, absolutely. You know, Ethan, the thing about the ASD group here is I'm just thinking, you know, we'll see when I count the motion, but like it's just so variable and underpowered, right? So if I have slight tiny bit of activation at P4.001. But I went down. But if I went down and I didn't correct for it, which is not okay, but you see activation in all the areas you would expect it to be. I'm just really underpowered.
And looking within a group, this changing how we're centering.
I think that might
that'll help, but I guess this still sounds like when you want to do a contrast between the groups, you're essentially coming back to the same thing, right? Where you're underpowered.
Yeah.
So we should do them. You know, I don't know.
They may not. I mean, the groups may not be different in this particular thing, based on. I mean, I only, you know, and I don't know if I will be able to tell if there is a difference.
Well, I mean, so if you recenter it, and ASD group looks a lot like the control group, fine. they both are using the speech network, and then we can see a significant difference. But if you recenter it, it doesn't, looks very, very different like it does here. We don't see a difference.
Well, let me show you the exploratory ROIs. So for this, I am calling anything significant if it has a p-value of less than 0.05, but doesn't have to be corrected because I'm exploratory within the speech network, the core speech network. So just to give you an idea of the power, nothing would have passed. I wasn't looking at correction, but the reason that nothing's highlighted on the AST group on the bottom is because nothing was significant after a correction.
With that, but not centering.
Right.
Right.
Right. So this just gives you an idea about
But
the general
it's showing you that.
But there's a lot of overlap in the areas that are significant. And my understanding, and I could be wrong, but my understanding was that if I was saying I'm doing an exploratory ROI analysis of the core speech network, I don't have to correct.
Well, you just have to
I'm not saying all those things.
Say that it's exploratory.
Yeah.
I think that's
If it's exploratory.
Right.
Yeah,
Right.
yeah, no, it is. And because there's hypothesis-driven ROIs, which are different.
That's fine.
Yeah.
That's fine. I mean, and this does kind of show what you were saying before, that
Like, it's there.
it's the activation, the pattern is there.
Yeah.
And then this will be a good way once you change the centering for us to see what kind of effect it has.
Yeah, and this is, remember, this is different. This is using the single subjects on the surface, but it's still, you can see the same.
And this is effect size. This is not.
Yes. Yeah, this is effect size. Yeah, they really are. And yeah, what I pulled out on the table is all the ones that are significant at a level of 0.05. So they're definitely patterning similar. So that's why, like, the between group not being significantly different wasn't throwing me that much. But especially with the amount of power that I have, it doesn't mean there aren't differences. I just, based on the fact that they are really similar, and I think any differences are going to be subtle, I don't know what I see. That's also why I'm trying to get a handle on if there's any variability with the ASD group compared to their behavioral measures and things like that. I also haven't looked between those sort of subgroups. This is just overall, just two different subgroups of ASD.
And it might be also worth looking at the motion covariate a little bit in more detail and to figure out whether is there a better way to correct for motion that might be like more effective at reducing the effect of motion or comparing or making the comparison between the two groups a little bit more, well, less noisy, basically. So the potential alternatives instead of motion is so look at the distribution of motion and just see how it looks, basically. Is it really a few subjects that are outliers, or is it a relatively normal distribution? Look also at the distribution of the you probably have like a number of valid scans for every subject, right? The number of scans that have been remain in the first level, that have been used for first level analysis after removing anything that is an outlier. And that might also a good indication of motion that of the actual motion that is relevant to the noise in the data. So that might be an alternative way of measuring motion and correcting the effect that might be nocive, detrimental to the data across subjects. Sorry, what was the question?
It's possible. So last time we met, it became clear that there was an outlier in terms of how the previous run of the ROI analysis was going, where you saw it. So it was kind of doing this.
That was with the more conservative art threshold.
Right.
That's
so,
not there anymore.
Well, what I'm wondering is if you make a less conservative threshold and include that subject, that somehow the motion that subject's contributing could be also off the charts relative to the others, and that somehow.
Yeah, so I'm pretty sure that was I think you're really right to look at it again, but that particular subject, I'm pretty sure is a subject that I just removed because they had 12 balance scans.
Okay.
I'm pretty sure.
Even after the increased threshold.
For 15.
Okay.
But yes, that's a really good point. Yeah.
One thing that we on the same plot the motion and see if there's that way, because it seems like, and this is the question that I was going to ask you up on. So if you have a subject just as with much greater motion, wouldn't that adversely affect
Yeah, definitely. I mean, it ends up acting as an outlier, basically, and introducing the motion covariate is basically just the same as trying to discount the effect of that subject from the rest of the analysis. So that's why the distribution of the motion covariates that you are entering makes a difference, because that kind of effectively affects how well or which aspects of the motion variability you are actually capturing by that covariate. So, I mean, in very general sense, it might be useful to plot, for example, for the ROI analysis that you have the data across all of the ROI, so you could just aggregate across all of the kind of speech areas and have a single number of the average activation in the speech minus baseline contrast for one particular subject, and correlate that, or just plot it versus the different motion covariates that we have, and see whether there are any better motion covariate that explains that variability across subjects in the average amount of speech minus baseline activation. And see whether there are outlier subjects in that regression, basically in that association, or are better ways to capture.
Change and outlier scans, like that kind of thing?
Sorry, I didn't get the question.
Sorry, I just wasn't sure. So plot it against things like
right. So you can write across average motion or the number of outlier scans, all of these subject level covariates that are indicative of how good or quality our data is, plot it against the average activation to kind of see whether you capture some large amount of variability better by some particular representation of this amount of motion, basically covariates.
Yeah, that's a good idea.
Because there is always going to be some variability across subjects in the average activation, speech minus baseline, that depends on many other factors. But motion is always a big thing. So if there is a big motion effect in your group, you're going to see a correlation between the actual average activation, speech minus baseline activation, and motion, even though some, I don't know, that variability is explained by many other things other than motion, but I don't know, motion typically is a very large effect.
Doesn't show by group, but this is all of my subjects mean motion. 5 are excluded.
For some reason, I only see kind of like a border of the screen.
Okay.
Let me see. Oh, there you go. Now it came back. Perfect. So what was the Y values in here, sorry?
Yeah, so the Y value is mean motion.
Mean motion. Okay, so yeah, so
those 5 are excluded. And so there is a difference that the ones with the higher motion are primarily the ASD group, but I do have a pretty even split in that once I get rid of those 5.
How about the numbers 20 through 30 at the bottom? Are those mostly ASD? Also?
I have to look at it again, but yes, because even after I get rid of the, I don't do any analysis with those 5 in it. So when I looked at differences between motion and they're significantly different, that is not including those 5. So I'm assuming that 20 to 30 are pretty much ASD. But of course, So, but I think I'll just see if it splits up really like that. And if it doesn't, I can look at something else. The problem with valid scans, I can look at percent valid scans. I've done that before. They have different numbers of runs based on compliance. So there's going to be less runs in the ASD group for the most part anyway.
So if
So I
that
looked
valid
at-
scan was broken down by run.
I don't,
Yeah.
maybe. I done percent valid scans, which can't stand by itself because, for example, that one that had 1 run and only had 1 run and then ended up having 15 valid scans, 50% valid scans, but the number of valid scans was much less. So
I don't know, the total number of valid scans, even if it's across multiple runs or one single run, it's typically indicative of the well, how much noise you're going to get in your first level estimates, right? So when you're looking at speech minus baseline, the more data that you have, which effectively is the more number of valid scans that you have, the less residual error you're going to get, and the more robustly you're going to estimate the speech minus baseline effect. So that's why it's a good measure, even though it might not be fully dependent only on motion, it might also depend on other factors like the actual number of scans that each subject underwent. Is still a very good indicator of how good data you have for each subject. So that's why it's also a potentially good covariate to introduce in the second level.
Okay, I'll take a peek at that. So every person besides that one that I excluded in these motion ones had over 50 valid scans. So I can look and see if that sort of variability within how many breaks down by group. So the idea is to find what best sort of splits the two groups and include that as a second level covariate.
Not necessarily splitting the two groups, but whichever thing explains most of the actual variability in some like general notion of activation, like an average activation across the entire speech network, or something that you expect to be relatively a strong effect, like a Speechman's baseline effect on average across all of the speech areas, which should be relatively strong. Whichever, like if it's a strong effect, you expect to have like a high average across all subjects and low variability across all subjects. So whatever explains that variability, if you have, is going to help you increase the sensitivity to that average effect. So whatever explains the most variability across subjects is the thing that you want to introduce in here, basically. Does it make sense? Because we expect that variability to be mostly introduced not by reasonable subject-to-subject variability effects, but by noise artifactual effects like the actual amount of motion and things like that. Because we are seeing a lot of variability across subjects, because we know that because we are seeing all of these very low-powered results of Speechman's baseline. So we know that there is too much variability, or at least much more than what we would expect, and we are trying to figure out which things would help us capture that variability best and to remove it from our analysis.
So I would essentially do a config file where I looked at all subjects and then whatever variable I was interested in and looked at.
Right. So the idea is to try to figure out which variable is the best way to it's a good variable control covariate that captures whichever things is happening that is affecting the quality of the data, the variability in the quality of the data across subjects. So we currently have the average motion because that is a reasonable measure to do that, but perhaps we can find a better measure. So first we would go through some sort of exploratory analysis without looking at the actual effects too much, just looking at a global measure like average activation across all of the regions and trying to see what things explain that variability. And once you figure out that and figure out which one is the variable that you want to use as a control covariate, then just change your second level analysis instead of using the motion covariate, use that covariate that we found to be most explanatory of the variability as a control covariate. Okay. Again, do the same thing, divide it into a covariate per group so that you can then look at the average effect within each group, controlling for that and all of those things. So just treat it is to see if we can find a better control measure than average motion, basically.
Okay. Okay. Yeah, that
makes sense.
Yeah, for sure. Yeah. I think that's about it.
I think so. Do you guys have any questions or the things that come up?
It was really helpful. We should talk about Thursday.
Right. So, well, the precursor, we're an hour in, so this will literally just be a precursor. You know, I'm going to bring the slides up because we have been sitting these things for a long time. I don't think we're going to get far enough. To discuss the ROIs, so I'm working on what would be the organization of this if you guys hadn't already done a bunch of this stuff already, because I keep pushing this off. So it seems like structural analysis stream is really what we're talking about. So we have the MRI stream, ETI stream, structural analysis stream, and really that's what FreeSurfer is. So now I'll mention a few things about FreeSurfer, and I think there's a lot to go over there that'll be useful long term. And what I'll do is mention those things, and then we come back. So for instance, burning recon all, we have scripts to do that. We have a standard way of doing that. I'll describe that. And then after that, we need to do some QA on that. And the way we've got this set up now is that Bobby's kind of taken care of that in the past. But we have nice set of slides to walk through that I can point to, and then at a future meeting, that'll be. So what I'm thinking is there's going to be this structural data processing
processing set of tutorials. That'll be one, but I'll jump ahead to what are the files that are generated from FreeSurfer that are useful for ROI analysis. Where are they? What are they? Where are they? And what are the bits, like what you would need to do with FreeSurfer to generate them. So how to use them. The way that FL is set up now, you could just point to them, right? Once you know where they are, you can point to them and they work. So it's getting there. I think with DTI, it's going to essentially be that same thing. But as with anything, there's more that you could do with them. So there is some. So there. Ultimately, what I want to have, and we do have, I just need to piece them together and maybe think about what we would want to do. This script. So when you run read.all, that's a function in FreeSurfer. then that does everything that we need. It generates these ROIs, but it's not our speech lab ROI. So we need to go in and then run another script that runs a few different processes to generate our ROIs, and then extracts the data from them. So and a couple of additional steps that need to be run. So having that all in the script, and we have that actually. Ricky to come up with one that does a lot of it. It needs to be modified to make sure that we we'll write stuff, but we'll do that. So I'll try to have that stuff done for the next time we meet. So I'd be up for trying to meet again on Thursday morning, but I could also do, like I said this yesterday, and the coming Monday this coming Monday actually would be fun too. So we can go back to Monday if you prefer. We do a bit of it on Thursday too. Whatever works for people.
I don't want to speak for other people, so I get them home.
I'm on vacation next week.
You're
But
away.
I will tune back into videos afterwards. But Connor, don't put it off. I would prefer you to meet and then we watch a video. I'm going to zoom in and out of the appointment, but I don't know how long it's going to take. So
Thursday morning.
also don't put Connor on. I'll try and be here, but I just can't.
So I thought I would be out Friday, but I don't have to be out Friday, so I could do something. I could be Friday morning probably a little bit later.
You have
Yeah.
lots of other people.
Yeah, what would you
Connor
guys?
and
What would you
everybody
guys
else.
prefer? What do you think?
I'm going to go ahead and stop the recording.
Yeah.
So we don't have to go through this.
Thursday, Friday, or Monday at
Yeah.
any time will work. So.
All right. Well, let me